What is the positive difference? That means we're going to subtract them, but just, find the positive bits. The difference between 2 and 7 is 5. Okay, it's minus 5 as well, but we're only considering the positive difference. You normally do that anyway, but it's just being careful. Between the numerator and the denominator, numerator is the top, denominator is the bottom, when the expression shown is written as a single fraction in its simplest form. All right, that means we need to write it in its simplest form. So to do this, what I can do is I'm going to write it out, and then I'm going to, this bottom bit's got a fraction within the fraction, so I'm going to times through by n plus 3. Okay, that's step 1. That's going to give me n squared plus 3n on top. Okay, I'm probably going to have to expand that out. And over here, I'm going to get n plus 1 times n plus 3 minus n plus 2. You might actually find it easier to just go straight from here to here. I'm just timesing the top by n plus 3, and I'm timesing this term by n plus 3, and then this term by n plus 3. Just be careful because we don't write the bracket, but there is a bracket here. We do this first and so on, so we have to minus the whole thing. But we're well on our way now, and I hope I've explained those steps clearly enough. I can expand the bracket here, n squared plus 4n plus 3, and then I get rid of this negative now, which is going to be minus n minus 2. That's going to give me n squared plus 3n plus 1. And therefore, the positive difference between the numerator and the denominator is just this bit here. The answer is 1. Let me just show you one other way you can do it. The answers do this. I wouldn't have thought to do it like this. I quite like my method, but you might prefer this one. And it's essentially the same, but it's to put the bottom over a common denominator itself. So I'll just write out the whole thing. So I'm not actually timesing top and bottom by anything. I'm going to leave the top as it is, but then I'm going to write this as n plus 1 times n plus 3 minus n plus 2 all over n plus 3. So I've done the same as what we do when we add fractions. If I've got like 1 plus a quarter, then actually I write it as 4 over 4 plus a quarter, and then I can add them. I've kind of done the same thing here, but I've done the subtraction at the same time. And I've just gone straight to 4 plus 1 over 4. What to do then? Well, I've actually got a number divided by a fraction, so we can write it as n divided by n plus 1, n plus 3 minus n plus 2. I mean, this is messy. Like it's kind of, it's a challenge anyway, really. And then I would change that to a times. Okay, and then we're basically back to where I was. Because when you times these, you can imagine this is n over 1. It's going to become n plus 3. This is quite interesting how you can use like a slightly different idea, but still get the same answer. I used equivalent fractions in my method. This used writing it over a common denominator and then division, but they are the same. So, from here, basically back to here, from which similar working can follow.